So we're going to start algebra today. And in this video, we're going to talk about algebraic expressions. An algebraic expression is basically a statement without an equal sign. And we're going to talk about the parts of expressions and the difference between them and equations. And let's start off with talking about the differences. So on the left-hand side here, I have some expressions. There's 3x plus 1, there's pi r squared, there's square root of 1 minus x squared. So neither of these have an equal sign in them. So they're kind of just statements. On the other hand, right-hand side, we have some equations. We have an equal sign. We have 5 equals 3x plus 1. We have a equals pi r squared. We have y equals 1 minus x squared underneath the square root. We could do a lot more with equations. The first one, we could solve it. The second one is a formula. The third one is an equation with 2 variables, so we can do a lot of things with that. We can graph it and whatnot. And we'll talk about a lot of that stuff throughout the rest of this course. But today, in this lesson, we're going to talk about expressions. So let's talk about some parts here. So let's look at 3x plus 1. Okay, this is an expression. It has what we call 2 terms. So 3x is a term and 1 is a term. Terms are separated by addition. So, and remember, we learned that subtraction is the addition of a negative. So when we're talking about terms with subtraction in them, we have to be a little bit more careful. Or with expressions with subtraction in them. So terms would be 3x and 1. We call 1 constant because it doesn't change. 3 would be the coefficient. And x, the variable. And the coefficient is a multiplier. It changes how much the variable could grow, so to speak. X is a variable, and that's because x could be whatever we want it to be. We could plug in 1, we could plug in 2. If we're solving, then we can find what x is supposed to be if we have an equation. And again, 1 is a constant because it's not changing. There's no variable attached to it. And I want to make a note. If I have x, just a variable x, that's an algebraic expression. And we can rewrite that as x times 1 raised to the first power. So if we see just a variable hanging out, we assume that it has a coefficient of 1 and an exponent of 1. And if you look at what we had above, we had, the pi r squared. So the coefficient there, I'm sorry, the exponent would be 2. We had the square root of 1 minus x squared. Again, you have an exponent of 2 by that variable. The square root is something else. We'll get to that later. So when we have expressions, one of the things that we're going to be told to do with expressions quite a bit would be evaluate. So what does that mean? So if I have some instructions, I want to know what 3x plus 1 is when x is 5. What that means is it wants me to plug this 5 in for the x over here. So here's how I'm going to do my work. I'm going to write 3. I'll multiply it by 5 because we're plugging 5 in for x. I'm going to add 1, and I'm going to follow the order of operations. So 3 times 5 is 16 plus 1. 16 plus 1 is 17. If I want to evaluate x squared plus 2x plus 3 when x is equal to, let's see here, let's plug in a -2. When x is -2, we don't need the parentheses there, but I'm going to use it when I plug it in. So I'm going to plug in -2 wherever I see an x squared. I like to use parentheses whenever I'm plugging in a number for a variable, because it helps me with my signs. It also reminds me that I'm dealing with something that was a variable and is being replaced. So -2 squared, that's -2 times -2. That's going to be a +4. Plus 2 times -2 is a, well, let's do the order of operations completely in order. So it's 2 times -2 and plus 3. I don't want to get ahead of myself there. So that was parentheses first. Well, there's no real parentheses to worry about. So exponents come up and we took care of the exponent. Multiplication, division from left to right. So I'm going to work on that middle term now. 4 plus a -4 plus 3. Now addition happens from left to right. 4 plus -4 cancels out, and I just get 3. So that's what happens when I plug in -2. And we're always going to, again, follow the order of operations. A lot of folks, if you get comfortable with this, you probably would have taken care of that step all at the same time. And if you're careful, that's okay. But to just illustrate order of operations, I chose to do one step at a time. So the other thing we could do is we could simplify algebraic expressions. So what does that mean? Well, let's look at a basic example here. Let's look at 3x plus 2x. So 3x and 2x are terms, and since they have the same base and the same exponent, we could say they have like terms. And this is kind of like adding 3 apples and 2 apples. What happens when I add 3 apples and 2 apples? Well, let's use the distributive law here. The distributive law basically says I can take this x on the outside, and I can add my 3 and 2 together following the order of operations. I get 5x. On the other hand, 3x plus 2y is already simplified. Spell that correctly. Sorry about that. So 3x and 2y, they're already simplified because I have a different variable here. Since I have a different variable, I cannot combine them. It's pretty much like asking 3 apples and 2 oranges. You can't really combine that in a meaningful way. Similarly, 3x plus 2x squared is already simplified as well, because I have a different base. Even though I have an x and an x in both terms, I have a different exponent. And so same base is different exponent. So those are not like terms. Let's look at a slightly more complicated example. And this will be the last one for the video. So let's look at 3x plus 2y plus x minus 5y plus 1. So I'm going to do a little bit of extra work here to illustrate why things work out. In the long run, most folks are going to, when they combine their like terms, they're going to do a lot of this in their head, and that's okay. If I want to combine my like terms, first let's identify like terms. So the 3x and the x are like terms because they have the same base and the same exponent. The 2y, and this is really going to be a negative 5y. I'll talk about that in a second. Those are like terms. And so what I want to do is I want to use a commutative law of addition to be able to get things next to each other that are common. So the X is next to each other, the Y is next to each other. You notice I didn't highlight the 1. Well, it's kind of by itself. It doesn't have anything in common. There's no other constant terms. What I'm going to do is I'm going to rewrite this with the idea that subtraction is the addition of the negative. Subtraction is the addition of a negative. So 3x plus 2y plus x plus negative 5y plus 1. So it doesn't look too different, but you do notice that I thought about this as addition of a negative instead of subtraction. That's going to help me when I use a commutative law because subtraction doesn't commute, but addition does. Oops. Let me do that correctly. So sorry about that. X plus 2y plus negative 5y plus 1. All right, so I have 3x plus x. So my like terms are now next to each other. And I can use the same idea that I did above and combine my coefficients. So 3 plus 1 is 4. So I get a 4x. 2 plus a negative 5 is a negative 3. And that 1 doesn't have any friends, so it just hangs out by itself. So don't forget it. Make sure you bring it down. And we can clean this up just a little bit more. We can use subtraction as the addition of a negative to turn this back into subtraction. So I get 4x minus 3y plus 1. So that's how you combine like terms. And I suspect most people are be able, with a problem like this, they're going to be able to go from the first step to that last step with a lot less work, and that's okay. But this is the mathematical reason why that works. We're going to talk more about terms in a lot more detail when we hit polynomials, and that's in a future video. So I will see you in the next one when we talk about solving some basic equations.